Hello, everyone, and welcome to today's technical deep dive. Today, we are going to dissect an advanced AWS IAM policy document. If you've ever struggled with scaling access control across multiple developers, environments, or mutable infrastructure, this session is for you. We will break down how to use attribute-based access control, or ABAC, and dynamic context variables to achieve precise, secure, least privilege permissions in AWS. Let's begin by understanding what problem this specific policy solves. In a fast-paced development lifecycle, engineers often need to manage elastic block store, EBS volumes, attaching and detaching them for backups, debugging, or data migrations. However, giving developers broad EC2 administration rights introduces severe security risks. This policy demonstrates how to write granular rules that delegate these exact operations safely. Looking at the JSON structure on this slide, we see a standard AWS policy syntax using version 2012-1017. The document contains a statement array with two distinct allow blocks. Each block focuses on a very narrow set of actions, specifically ec2.attachVolume and ec2.detachVolume. By restricting actions strictly to these APIs, we eliminate unnecessary exposure to instance termination, security group modifications, or volume creation. Let's examine the first statement in detail. Notice the resource pattern. It targets EC2 instances globally. arn/AWS/EC2:*:*:instance/**. On its own, this would be dangerously permissive. But look at the condition block. It uses a string equals operator, checking for the tag key department with the value development. What does this mean practically? A user governed by this policy cannot touch production, staging, or QA instances. They can only attach or detach volumes to instances explicitly tagged as belonging to the development department. Now let's look at the second statement. This one targets EBS volumes. arn/AWS/EC2/****volume/. Look closely at the condition. It evaluates the tag key volume user against $AWS:*username. This is a powerful concept called dynamic variable interpolation. AWS evaluates this variable at runtime against the active IAM username of the caller, whether it's Alice, Bob, or a federated role user. This means Alice can only manipulate volumes specifically tagged as owned by Alice, and Bob can only touch volumes tagged for Bob. It prevents developers from accidentally or maliciously interfering with each other's storage. This policy is a textbook example of three core cloud security pillars. 1. Attribute-based access control, ABAC. AWS Attribute-Based Access Control, or ABAC, is an authorization strategy that defines permissions based on attributes. In AWS, these attributes are implemented as tags. Access is granted when the tags matching a user or role align with the tags on a resource. In this scenario, scaling permissions via tags rather than hard-coding resource ARNs or static user groups. 2. Least privilege. AWS least privilege is a security rule. It means giving users, apps, and roles only the exact permissions they need to do their work, and nothing extra. In this scenario, permitting only two necessary API actions, attach and detach, while blocking everything else. 3. Dynamic variables is a dynamic placeholder used inside IAM JSON policies. AWS replaces it with runtime context from the API request, such as the caller's identity, allowing you to write one flexible policy for multiple users. In this scenario, utilizing AWS context keys like AWS:*username to bind resource ownership securely to individual human identities. To understand how IAM evaluates this multi-statement policy, let's walk through a matrix of common scenarios. Scenario A. Developer Alice wants to attach her personal volume to a development tagged instance. Both conditions pass, so IAM returns an allowed verdict. Scenario B. Alice tries to attach her volume to a production-tagged instance. Even though the volume tag matches her username, the instance tag check fails because the department is not development. IAM denies the request. Scenario C. Alice tries to attach Bob's volume to a dev instance. The instance check passes, but the volume tag check fails because volume user doesn't match her username. Again, IAM denies the request. Both conditions must be independently satisfied for the operation to succeed. Implementation recommendations. Before deploying a policy like this to production environments, keep these best practices in mind. First, enforce strict tag hygiene across your infrastructure using automation pipelines or AWS config rules. AWS strict tag hygiene is the practice of enforcing rigid, standardized, and clean key-value metadata rules across cloud resources. Second, always bundle these policies inside permissions boundaries to prevent privilege escalation. An IAM permission boundary is an advanced feature that sets the maximum possible permissions an identity-based policy can grant to an IAM user or role. It acts as a safety limit, ensuring that even if an administrator mistakenly grants full administrator access to a user, that user can never exceed the boundaries defined by the boundary policy. Finally, audit your CloudTrail logs regularly to ensure that resources are consistently tagged. Regularly auditing your CloudTrail logs is an excellent final step to guarantee that resource tagging compliance is maintained across your AWS environment. That concludes our technical walkthrough of this advanced IAM policy. I hope this gives you fresh ideas on how to secure your workload using tags and context variables. Thank you for your time. Please subscribe and share.